Okay, this video is about system of linear equations, how to solve a system of linear equations in two variables. For example, x and y are the variables here, and we are going to focus more on the graphical solution. What you are seeing is the software GeoGebra. That's the one I am using here to draw the graphs of the straight lines. Okay, here I am using the equation in the form y equal to mx plus b, y equal to slope times x plus the y-intercept. You see the equation of the pink line here, the equation of the pink line here is y equal to negative 0.4x plus 1.3, where this negative 0.4 is a slope of the pink line. That's here, that's controlled by this here. A is the slope of the pink line, and S is the slope of the blue line, and B is the intercept of the pink line, and C is the intercept of the blue line. I can change the intercepts here. Now the intercept of the pink line changes. I will get a different line. Already we know when the slopes are equal, the lines are parallel. When the slopes are not equal, the lines are not parallel. For example, we fix the slope of the pink line at exactly 1, and similarly the slope of the blue line also exactly at 1. We can change the y-intercept here like this. Now you see there the lines are parallel. The lines are parallel. When the lines are parallel, they never meet at all. When they don't meet, there is no solution. When the lines are parallel, there is no solution. When the lines are parallel, there is no solution. So this is one of the case for a system of linear equations. You are given two equations. When the lines are parallel, that means the slopes are equal, and the y-intercepts are not equal. The slopes are equal, but the y-intercepts are not equal. Then there is no solution. But there is a case. Here when the y-intercepts are equal. When the y-intercepts are exactly, for example, -1 here. Here also I am going to keep as -1, both into -1. Both gradient, both the y-intercepts are -1. When the y-intercepts are -1 and the slopes are equal, then the lines are overlapping. When they are overlapping, there are infinite solutions are available. So they intersect at more than one point. Many points they are intersecting. All the points are intersection. So we call it as infinite solution. So this is case number 2. Maybe you can note down. Already we have seen case number 1. When the slopes are equal, the y-intercepts are not equal, there is no solution. I repeat, when the slopes are equal, the y-intercepts are not equal, there is no solution. Now the case number 2. Case number 2 here, the slopes are equal, the y-intercepts are equal. The slopes are equal, y-intercepts are equal, both represent same straight line. Then there is infinite solution. We call it as infinite solution. Okay, we call it as infinite solution. Now when the slopes are not equal, for example, this slope is different and the blue line slope is different, the y-intercepts are not equal. Whether they are equal or not, we don't care about it. But the slopes are not equal. When the slopes are not equal, there is only one solution. When the lines are not parallel, unique solution, there is called only one solution, that is the intersection of the two lines. Here the solutions are negative 1.14 and 1.19. These are the solutions. When the slopes are not equal, but we don't care about the y-intercepts. Even the y-intercepts are equal, still we have solution. because the slopes are not equal. When the y-intercepts are equal, so they have to meet on the y-axis because they both have same y-intercepts. So both the lines meet at the y-axis at the same point. So when the slopes are not equal, when the y-intercepts are equal, then we know the solution immediately. No need to solve. We know the solutions of the system is 0, the y-intercept, where x is a 0, x value is 0 and y value is the y-intercept, provided the slopes are not equal. So when the slopes are not equal, the lines are not parallel. When the lines are not parallel, definitely they have to meet at a point, and that point may be any point on the Cartesian plane, but if the y-intercepts are equal, they will meet on the y-axis at the same point. Okay, now you change the y-intercept, you see there is a different intersection point. There's a solution is unique. You can get the x value and y value. It will be satisfied by both the equations. So this is case number 3. So for any system of linear equations, there are 3 possibilities. The first possibility, case number 1, is when the lines are parallel, no solution. Lines are parallel, the y-intercepts are not equal, so they have no solution at all. When the slopes are equal and also y-intercepts equal, the lines are overlapping, then we have infinite solutions. In this case, the slopes are equal, the y-intercepts are equal, and they are overlapping lines, then infinite solution. The third case, when the lines are not parallel, that means slopes are not equal, we don't bother about the y-intercepts, there will be a unique solution, only one solution. This is case number 3. Okay, so for any system of linear equations, graphically we can find whether they have unique solution or no solution or infinite solution. Later we will solve algebraically. In another video we will solve it algebraically. So now you have some practice. You just write down some of the equations, draw the lines on the graph paper and check it out whether they have unique solution or no solution or infinite solutions. Is it okay?